Restoring the Columbia River corridor. Transitioning the Central Plateau. Preparing for the future. Some of the toughest radiological and chemical cleanup challenges in the world are at the Hanford site in Washington State. Hanford is the largest of the 3 original defense production sites founded in World War II as part of the Manhattan Project. Over its 40 years of operations, Hanford produced approximately 64 metric tons of plutonium, nearly 2/3 of all of the plutonium produced for government purposes in the United States. Now, Hanford's mission is cleanup, to reduce risk and protect the environment. These cleanup challenges include more than 50 million gallons of highly radioactive and hazardous chemical waste held in 177 underground storage tanks, 67 of which are known or suspected to have leaked. 2,100 metric tons of spent nuclear fuel deteriorating in underwater storage basins near the Columbia River. Nearly 270 billion gallons of contaminated groundwater spread out over about 80 square miles. Over 1,900 stainless steel capsules of radioactive cesium and strontium containing about 37% of the site's total radioactivity. Over 790,000 cubic meters of solid waste. More than 1,700 identified waste sites and 500 contaminated facilities. And 4 metric tons of plutonium. DOE and its contractors have made significant progress over the last few years, including resolving major underground radioactive tank waste safety issues and enabling all Hanford tanks to be removed from the Congressional Watch List, removing the pumpable liquids from 131 of the 149 single-shell tanks, deactivating 2 massive chemical processing plants, moving about half of Hanford's spent nuclear fuel out of the underwater pools near the Columbia River to safe, dry storage in the center of the Hanford site, stabilizing and packaging all of Hanford's plutonium solutions and half of its plutonium residues for eventual shipment off the Hanford site for disposal, actively dealing with contaminated groundwater plumes, dismantling reactor complexes, and cocooning 2 reactor cores for interim safe storage with 3 others well underway. Moving about 4 million tons of contaminated materials away from the Columbia River shoreline, about 40% of the total, and sending hundreds of drums of transuranic or true waste to the Waste Isolation Pilot Plant in New Mexico for permanent disposal. DOE and its contractors have transitioned from just managing risks to actually reducing them and forging ahead on the cleanup efforts. But existing DOE schedules had the work continuing to 2070 at a cost as high as $90 billion. Without a new focus on early risk reduction and completion, the job would take too long and cost too much. So drawing on the ideas that emerged from a year-long partnership with its contractors and state and federal regulators, DOE developed a plan for cleanup that will dramatically reduce risks to people and the environment and complete the cleanup mission by 2035. To do this, DOE will pursue 6 strategic initiatives, each aimed at a key component of risk reduction. Hanford's Columbia River corridor consists of about 210 square miles. Its near-term cleanup challenges include 50 burial grounds, 579 waste sites, 357 excess facilities, and 7 plutonium production reactors adjacent to the Columbia River. Under this strategic initiative, DOE and its contractors will cocoon 6 reactors for interim safe storage, remove or provide for the long-term stabilization of all remaining wastes that threaten the Columbia River, take down most of the remaining buildings, and with the exception of 2 burial grounds requiring the development of special handling capabilities, all but eliminate the near-term threat this area poses to the groundwater. 53 million gallons of liquid, sludge, and solid waste is stored in 177 underground tanks in the central part of the Hanford site, just 7 miles from the Columbia River. Many of these tanks are decades beyond their design life, and even the newer double-shell tanks are showing signs of age. Removing the waste from tanks, treating the waste, and closing Hanford's tanks is vital to protecting our workers, the public, the Columbia River, and the environment. Strategic Initiative 2 calls for DOE and its contractors to accelerate activities to retrieve waste from tanks and begin the closure process for single-shell tanks 10 years earlier than the current schedule. After removal from the tanks, waste will be vitrified. In the vitrification process, glass-making materials are added to the waste. The mixture is then heated to over 2,000 degrees Fahrenheit in a large melter. The result is an exceptionally sturdy and stable form of glass. The high-activity glass in robust metal containers will eventually be transported off-site for disposal at the National Geologic Repository. The low-activity glass, also in robust metal containers, will be disposed of at the Hanford site. DOE is planning to complete the treatment of tank waste by 2028 using the vitrification plant supplemented by parallel treatment technologies. Construction of the waste treatment plant started in July 2002, and the plant is scheduled to begin operations in 2007. Beyond the tank waste, Hanford's most urgent threats to human health and the environment are posed by remaining inventories of spent nuclear fuel, plutonium, and other materials in forms currently unsuitable for long-term storage or disposition. This initiative is aimed at significantly reducing the near-term risk by stabilizing these materials, packaging them into long-term storage containers, and consolidating them into fewer facilities. This offers more protection, greatly reducing the risk to the environment, and lowers the annual cost to manage the waste and maintain the safety systems. 2,100 metric tons of spent nuclear fuel, about 80% of DOE's nationwide inventory, is in the K-East and K-West reactor basins along the Columbia River. Stranded in water-filled, leak-prone pools when fuel reprocessing was halted in the late 1980s, the fuel is deteriorating. In December 2000, DOE and its contractors moved the first fuel out of the K-West Basin into an engineered canister, conditioned it for dry storage, and placed it in a special facility for safe long-term storage until it can be shipped to a National Geologic Repository for permanent disposal. In November 2002, workers began removing the fuel from the much more contaminated K-East Basin, where much of the fuel is severely corroded and in open canisters. To reduce worker radiation exposure and expedite the K-East Basin process, workers are using a fuel transfer system to move the fuel into the K-West Basin for washing and loading prior to sending it to the drying facility and long-term storage. As part of accelerated risk reduction, all of the fuel, sludge, water, and debris will be moved out of the K-basins by September 2006. One of the greatest environmental and security risks at Hanford is the approximately 4 metric tons of plutonium-bearing materials in various liquid and solid forms at Hanford's plutonium finishing plant. These materials must be stabilized using several different processes, appropriately repackaged, and shipped to other locations for reuse, long-term storage, or final disposition. This process is underway and will be complete by May 2004. In addition, plutonium and other hazardous materials exist in hundreds of glove boxes and miles of ventilation ducts at the plutonium finishing plant. Workers will characterize, remove, package, and dispose of this material by 2006. Hanford's 1,936 cesium and strontium capsules contain about 130 million curies of radioactivity and account for about 37% of the site's total radioactivity. The stainless steel containers are stored in pools of water, which remove heat and provide radiation shielding. DOE is planning to put the capsules into dry storage to reduce vulnerabilities and increase environmental protection. Hanford has more than 40,000 drum equivalents of previously generated mixed low-level waste and suspect transuranic or true waste, and a similar amount of suspect true buried in retrievable storage. As part of accelerated cleanup, Hanford will speed the retrieval of some of the worst buried transuranic waste with the goal of completing these initial operations by 2010. Hanford's solid waste commitments include accelerating by 4 years the treatment and disposal of about 14,000 cubic meters of mixed low-level waste, accelerating transuranic waste operations by deploying additional resources, enabling Hanford to certify for shipment up to 4,000 drums a year for permanent disposal at the WIPP in New Mexico, and accelerating to 2006 the retrieval of 15,000 drums of suspect transuranic waste from the burial grounds. The Central Plateau consists of about 75 square miles near the middle of the Hanford site and contains about 900 excess facilities, including 5 massive chemical processing facilities, or canyons, as well as about 800 individual waste sites. This initiative will accelerate cleanup by grouping cleanup work in order to make best use of resources, increase efficiency, and get to higher priority work sooner. DOE will develop a schedule that sequences waste site and facility cleanup to focus first on those areas that pose the greatest potential threat to health or the environment, including groundwater. DOE and its contractors will also undertake an innovative approach to dealing with Hanford's canyon facilities by beginning the U-Plant Regional Closure Project, which will include final disposition of the large U-Plant Canyon facility, the smaller buildings around U-Plant, and remediation of nearby waste sites. This will mark the first closure of a large facility in Hanford's Central Plateau. This project will also serve as a template for closure of other large Hanford facilities and their nearby waste sites. Protecting the groundwater is critical. It's an important resource and the primary pathway for contaminants from Hanford to reach the Columbia River. Protection of the groundwater requires the development and implementation of a strategy to limit and control the continued migration of contaminants already in the soil and groundwater. There are specific actions to take now, such as eliminating leaking water lines that drive contaminants to groundwater, controlling surface water, pumping and treating the most hazardous contaminants from the groundwater, remediating strontium and chromium sites, and remediating high-risk waste sites. DOE and its contractors have gained a great deal of knowledge and cleanup experience over the last few years, a momentum that increases confidence that the 2035 end date for cleanup is achievable. But there are still many uncertainties, technical, financial, regulatory, that will affect Hanford cleanup for a long time to come. To navigate through those uncertainties, DOE will continue to work closely with its regulators, area tribes, and stakeholders to outline a framework for cleanup that protects people and the environment and makes sense. It will pursue the science and the technology needed to solve some of the site's toughest problems. And it will continue to identify new strategic initiatives that can yield additional results. DOE's commitment is to harness every available resource, technology, partner, and idea possible to finish a high-quality Hanford cleanup by 2035 or sooner. It's the right thing to do for the Northwest and the nation. For more information, visit www.hanford.gov or call 509-376-7501. Spread out over about 80 square miles. Over 1,900 stainless steel capsules of radioactive cesium and strontium containing about 37% of the site's total radioactivity. Over 790,000 cubic meters of solid waste. More than 1,700 identified waste sites and 500 contaminated facilities. Over its 40 years of operations, Hanford produced approximately 64 metric tons of plutonium, nearly 2/3 of all of the plutonium produced for government purposes in the United States. Now, Hanford's mission is cleanup, to reduce risk and protect the environment. These cleanup challenges include more than 50 million gallons of highly radioactive and hazardous chemical waste held in 177 underground storage tanks, 67 of which are known or suspected to have leaked. 2,100 metric tons of spent nuclear fuel deteriorating in underwater storage basins near the Columbia River. Nearly 270 billion gallons of contaminated groundwater restoring the Columbia River corridor. Transitioning the Central Plateau. Preparing for the future. Some of the toughest radiological and chemical cleanup challenges in the world are at the Hanford site in Washington State. Hanford is the largest of the 3 original defense production sites founded in World War II as part of the Manhattan Project.